Alright guys, today we're going to talk about the polygon angle sum theorem. We talked about the triangle angle sum theorem, which just stated that each triangle, the sum of all the angles in every triangle is going to be 180 degrees. Today we're going to talk about polygon angle sum theorem, which I think covers the rest of the different polygons that we'll look at really throughout the year. We're going to be able to identify, name, and describe polygons, tell whether they're convex, concave, regular, etc. We're going to use the angle sum theorem. We're going to be able to find the measures of all the angles inside of a polygon and all the angles on the exterior of a polygon. Okay, so before we go through and do all of that, probably need to get familiar with our vocabulary. Okay, so our vocabulary is here written out for you. Let's go through it just a little bit. An equilateral polygon is just a polygon with all of the sides congruent, so equal lateral sides. A polygon with equal sides. Okay. Equiangular polygon is a polygon with all the angles congruent. Okay. And then a regular polygon, this usually trips people up, so make sure you pay attention to this. It's not just like regular, like, oh, that's what I'm used to. A regular polygon is a polygon that is both equilateral and equiangular. Okay, so regular means something more mathematical than just it's the usual polygon. Alright? Alright. So look at that vocabulary, make sure you study it and get kind of acclimated to it so you can use it. Alright, today we're going to talk about the polygon angle sum theorem, which deals with convex polygons. Okay, so a convex polygon is a polygon where there's no line that contains the side of the polygon contains a point in the interior of the polygon. So here's an example of the convex polygon. And what you could do is, if you look at the vertices here, as you connect the vertices, if you connect them with the line, okay, and they're already connected by a line here, notice that there's no lines that are no points that are not connected on the outside. Okay. Now, a concave polygon is just a polygon that's not convex. What you can see is that a side is kind of caved in. Okay. If you look at this polygon, this is a polygon. Okay, it's all of its sides are connected and closed, but it's concave, and you can see that if we look at these points, this vertex, this point, will be considered inside these points. So you know this is an interior point because the side contains an interior point of the polygon, because a vertex is in the interior of the polygon, this would not be considered a concave polygon. I mean, a convex polygon is concave because it's caved in. That's how I remember it. Okay. Alright, and that's important because our triangle angle sum theorem works for our convex polygons, but it won't necessarily work for our concave polygon. Another thing that we'll hopefully be able to do today at the end of this lesson is to be able to name polygons based on the number of sides that they have. Okay, here at this table we have the common names for our polygons. Okay, one that trips people up, I'll point out, is the quadrilateral. Okay, people like to say square and rectangle a lot, okay, because you kind of know what those are, especially if you're looking at it. But we're just naming this off of the number of sides. Remember that square is a little bit more than just having 4 sides, and a rectangle is a little bit more than just having 4 sides. Okay, we have to have a little bit more information to call them squares and rectangles. So if we know it has 4 sides, we call it a quad, for trilateral, 4-sided. Alright, and then all these other ones, I think you've heard these words for: triangle, pentagon, hexagon, octagon, nonagon, decagon, dodecagon. Okay. Notice that all the numbers are not included in this table. Okay, there are names for other sides, but these are going to be the ones that we need to be familiar with. I know that a 7-sided polygon is called a heptagon. but nobody really calls it that. I don't know what happens. I mean, people can call it that, but these are the ones that we expect you to know. Okay, so they got numbered sides names for all the way up to like 10,000. But these are the ones we expect you to know. If something happens that's not in this table, it'll probably be called an n-gon. So if I say, you know, a 15-gon, it's pretty easy to know. Oh, that means it has 15 sides. Okay, and that information we'll be able to use to, I guess, find any information that we want about the angles in a polygon. Okay, so this is something that you're going to have to spend more time with on your own, just looking at it, making sure you get those together. That you know, if I say octagon, it means 8. If I say non-gon, it means 9. Alright, so a couple examples we're going to go through and see if we can classify these polygons as convex or concave, say whether it's regular, and then name it by its sides. So number one, I'm looking at it, it has 1, 2, 3, 4 sides. So I'm going to call this a quadrilateral. Okay. Again, I don't want to call this a rectangular square because that's not what we're naming it based off of the number of sides. That's all we're naming it off. 4 sides, quadrilateral. Is the polygon convex or concave? Is it one of its sides caved in? No, none of its sides are caved in, so it is convex. Is it regular? Remember, regular doesn't mean like, oh yeah, I'm used to seeing it. Is it regular? No, not regular. It's not regular because all the sides aren't the same. Okay, these pairs and then this pair, they're different. Okay, all the angles are the same. It's equal angular, but it's not regular. Alright, number 2. Based off the number of sides, we got 1, 2, 3, 4, 5, 6, 7, 8 sides. So this would be an octagon. Octagon, 8-sided. Is the polygon convex or concave? Well, I can see that these sides are caved in, like I pressed them in. It's caved in. Okay, so it's not convex. It is a concave polygon. Okay. I could say it's equilateral though. Equilateral. It's not regular. And I'm pretty sure that all the angles aren't going to be the same. But it's equilateral. You can pause it if you want to and try these two if you on your own. I'll continue right now. If you want to count 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. Okay. It is convex. None of the sides are caved in. And it is regular. Okay. All the sides and all the angles are the same as equal angular and equilateral. I guess, looking back, we could say that this is not regular, but we could say this is equiangular. Okay. Alright. Looking at this triangle. Or triangle. Don't make that mistake that I just made. There's 1, 2, 3, 4, 5. There's 5 sides. It's a pentagon. 1, 2, 3, 4, 5. Yep, it's a pentagon, but it's concave. It looks like 2 triangles put together. Is there anything about this? No, I'll just say not regular, not anything. Okay, because it's not all the sides aren't the same, all the angles aren't the same. Just a different figure. All right, on to the next page. All right. We had a triangle angle sum theorem, and what our triangle angle sum theorem said was every triangle has 180 degrees. The sum of every triangle is 180 degrees. Alright? Our triangle angle sum theorem, we can look at it. If you want any extra stuff on this, I'm sure I can attach a different video of somebody going through and showing the triangle angle sum theorem. But look at a quadrilateral really quick, four-sided figure. If you connected its vertices, the new line that's created would create two triangles. Okay, this triangle would have 180 degrees. This triangle would have 180 degrees. There's 360. Okay, a different way to do that is just the polygon angle sum theorem. Okay, the polygon angle sum theorem basically says, well, it finds the number of triangles and times it by 180. Okay, without drawing it. So our polygon angle sum theorem is n minus 2 times 180. Okay, n stands for the number of sides. Number of sides. Okay. So let's look at this example, and then we will go back. I guess whenever we get to the corollary, we'll talk about it. So it says find the sum of the measures of a heptagon. A heptagon, like I said already, 7 sides. Okay, it wasn't in that table, but I wrote it down by it, so maybe it's something you need to write by it. So it has 7 sides, so I'm going to say, well, that's going to be 7 minus 2 times 180. What's 7 minus 2? 5. The measure of a heptagon is going to be 5 times 180, and that is 900 degrees. So, while I don't know all the individual angles, I'll know that the sum of the measures of a 7-sided figure, or 7-sided convex polygon, because it only works on convex polygons, it's going to be 900. Okay. Now, number 2 says find the measure of each angle of a regular pentagon. Okay, so we're going to kind of just go through this, and then I'm going to show you how it connects to the corollary. Okay. So, of a regular pentagon, I know that means it should have 5 sides. So I'm going to say, okay, the sum of it's going to be the number of sides minus 2 times 180. It's 3 times 180. That's 540. Okay, the sum is 540. Let's draw a really quick pentagon. I'll try to. Okay, and we'll pretend that this is a regular pentagon. That means all the sides are the same, all of the angles are the same. Alright, so if this whole thing is 540, everything is 540. I have 1, 2, 3, 4, 5 angles. Notice that the number of angles I have is the same as the number of sides. And so if I want to find the measure of each angle, I'm going to say, well, that's 540 divided by 5. Which is 108. The measure of each angle is going to be 108 degrees. And that's what our corollary says. You can find the sum of all the angles and divide it by the number of angles. In this case, the number of angles is always going to be equal to the number of sides. Just works out that way. Alright, so you can pause and try these next 2 on your own, and I'll try to go through them quickly so you can see the answers. So here's what it should look like. It should have 6 sides. Hexagon is 6 sides times 180. 4 times 180, which should be 720. Okay. Find the measure of each angle of a regular octagon. Octagon is 8. 8 minus 2 is times 180, so that's 6 times 180. 600, 480, 1080. Okay, 1080 is the sum. I'll do 1080 divided by 8. Okay. And that is going to give me, see if I can do this on my own. 135. Hope so. Yep. Alright. 135. Alright. So each measure of a regular octagon should be 135 degrees. And that's our answer. Okay? Hopefully you got those right. Alright, now here's how we're going to use this polygon angle sum theorem. This is how we can do it. We can find the measure of each angle of a polygon if we have enough information. So here's an example. We've got this, I don't know what it is. I'm going to count the sides so I can know what to work with. 1, 2, 3, 4, 5. 5-sided figure. So we got a pentagon. I'm just going to write it down so I know. Okay, we got a pentagon and we want to find the measure of each angle. Notice what they did for us. They told us 1, 2, 3 the angles, and they said this one's x plus 5 and this is x. How am I going to find these x's? Well, I should say, okay, the total of this thing has to be the number of sides minus 2 times 180. So 3 times 180, which is 540. So all these things together should add up to 540. So I'm going to make that as an equation. 106 plus 94 plus 135 plus x plus 5. Okay, so what I did there is I just added all these sides together to make 540. I want to simplify this. This is 335 plus 2x, I think it's plus 5, so I guess 340 plus 2x. Okay, so I have 340 plus 2x equals 540. Doesn't look like it's going to be too hard to solve. 2x then should equal, subtract 340 from both sides, 200. That means x will equal 100. Not really answering the question because they said find the measure of each angle. This angle then would be 105 degrees. This angle would be 100 degrees. Right? Let's do the same thing for this one. Again, you can pause it if you'd like to, so you can try it on your own. It's 1, 2, 3, 4 sides. So 4 minus 2 times 180, 2 times 180. And if you just know the answer, you can, but I want to make sure I'm showing you how I'm getting the sum each time. So it's 360. I should add these together. 118 plus 72 plus 5x plus 3x plus 10. So I have 8x plus, that will give me 90, 200 equals 360. 8x then will give me 160, and so x is going to give me 20 degrees. Okay, and so I can say that the angle U equals 20 times 5, which is 100 degrees, and I can say that angle V equals 20 times 3, which is 60, plus 10, 70 degrees. Okay, rounding this off. Final theorem that we're going to talk about is the exterior angle sum theorem. And the exterior angle sum theorem says this: the measure of the exterior angles of any polygon is 360 degrees. Okay. And so what you can see is that at each of the different vertices, or vertexes, singular and plural that, we only use one angle. So at this vertex, I'm only measuring one angle. At this vertex, I'm only measuring one. At this vertex, one. At this vertex, one. Okay, all that. If we do that, then the sum of the outside of all of them should be 360 for every single polygon. And I just like to think of it like this: if I have a triangle, if I have a circle, if I have a square, or a rectangle, or a dodecagon, whatever it is, I can always draw a circle around it. Okay, like right around it, and so that'll be 360 degrees. I don't know if that's mathematically the way that works out, but it helps me to remember that the outside is always 360, because I remember that a circle is 360. Okay. All my Harry Potter fans, I don't know if that's little try wizard thing. I don't know. Alright, so we're going to find the exterior angles. We're going to answer these questions knowing that the exterior angles should add up to 360 degrees. So it says find the measure of one exterior angle of a regular nonagon. Here's how we can do this. A nonagon. I don't know how to even draw that, but nonagon has 9 sides, right? Right. Okay. So nonagon has 9 sides, and with our polygon, what we can do is we can say, well, if it's regular, what does that mean to us? Regular will mean that all of our angles are the same. Okay, all of our angles are the same. And we don't necessarily need to know what the angles on the inside are right now, just find the exterior. But I know that if my inside angles are the same, what can I assume? Well, what should you know about the outside angles? They're going to be the same as well. And so a regular 9-sided figure, see, all the exterior angles should add up to 360. How many exterior angles are there going to be? 9. 360 divided by 9 should give me 40 degrees. Okay. And so I know the measure of one exterior angle of a regular nonagon will be 40 degrees. Okay. I don't necessarily need a picture for that. Alright. But I want to show you how we can do this if that was kind of like over your head. How we can do this better with the picture. So it says find the measure of each angle of this regular polygon. Well, I see there should be 6 sides. Are there? 1, 2, 3, 4, 5, 6. There are 6 sides. And so regular again means that all the polygons should, all the angles should be the same. So since there's 6 angles and the sum is 360, 360 divided by 6 should be 60. All these angles should be 60. Just to show you this is what's happening. I can do the polygon angle sum theorem and I can say, well, that's 6 sides minus 2 times 180. That's 4 times 180. That's 720 degrees, right? And there's 6 angles because this looks like this is a hexagon. Okay, so that's 1, 2, oh. So each of these interior angles, what I just found was the interior angles. Each of these interior angles is 120 degrees. And I can do that for all of them, but I won't. Okay. Each of these is 120 degrees. Okay. Now I want you to notice that these angles, this interior angle, this exterior angle, make a straight line. Okay. Straight line always equals 180 degrees. So since this is 120, its exterior angle, its linear pair, the supplement, should be 60. 180 minus 120. Okay, so a couple different ways to figure that out. You can pause it and look for these last examples and then see if you got it right. So there we go. One exterior angle of a regular 12-gon, okay, 360 divided by 12 because it's regular, it means all the sides should be the same. And so that could be 30 degrees. Okay, measure of each of these. Regular polygon, regular, all of them are the same. There's 1, 2, 3, 4, 5 sides. So 360 divided by 5, which should give me 72 degrees. So each of these angles is 72 degrees. Alright, hope this helps you out. We'll look at some problems after this.